Hi everyone, I'm Badrish Chandramouli from the database group at Microsoft Research, and this demo is on Faster, which is an embedded key value store for state management. Faster is open source on GitHub at the URL shown here, and I'll give you a short description of what it does today. So we are witnessing this huge growth in data-intensive applications and services across the cloud and edge. For example, you have these per-device aggregates that you need to track in an Internet of Things kinds of scenarios, which are quite difficult to do. There may also be per-user machine learning models, statistics, metadata, and this kinds of huge state that applications across the cloud and edge need to both store and update in real time. The state that is handled by such applications that work across the cloud and edge today exhibits several characteristics. First of all, the state is so large that it often does not fit in the main memory of a single machine. Further, the kinds of operations that you do on it are often update-intensive operations. So, for example, I want to look up a particular device and update its machine learning model. Or if you're performing some kind of aggregate, per-device aggregate of, say, machine telemetry, then you might have to keep some telemetry data like CPU or memory utilization for every machine or device in your data center. Today's solutions for handling such large amounts of state are basically falling into two categories. One is that you scale out for memory and keep everything in the main memory, which is a very expensive proposition. On the other hand, you may use today's key value stores, which can do the job but are very slow and not sufficiently performant or expressive for today's modern cloud edge applications. We introduced Faster, which is a concurrent key value store for such kinds of update-intensive operations. It supports a combination of lookups, updates, and atomic read-modify-write operations by key. Further, it can handle state that is larger than memory. So it automatically is an integrated key value store that offloads to secondary storage and keeps the hot working set in main memory. And the interesting thing here is that if your working set happens to fit in memory, the performance of Faster is identical or better than the pure in-memory data structures that are used for this purpose today. Faster is written as an embedded library in both C# and C++, and it can work with any tiered storage backend. For example, if you're a device, you may be able to use your local memory, some local SSD or storage device, and finally tier it down to the cloud storage, which may be the final tier of your tiered storage hierarchy. And the application is unaware of this tiering, and the system takes care of caching the hot working set in the main memory. Very briefly, the technical highlights of Faster include technologies to do concurrent latch-free data structures, which we will not talk about in this demo, but you should check out our paper at Sigmod for the details. Overall architecture consists of a hash index, as shown here, that basically talks to a tiered storage, which basically consists of the in-memory region, a read-only region, which is also in memory, and then the stable region. The key technology highlight of Faster is that when the data is in memory, it allows you to perform what is known as an in-place update, rather than the read-copy update, which is usually performed for log structured storage. We do perform read-copy updates for the older data, which is stored on the secondary storages. Faster has lots of use cases, including, for example, streaming state management, serverless and cloud state management, and other applications. It uses a new recovery model that we talk about in a paper this year. And let's now go to the demo, which will showcase Faster. The demo, we are essentially running a popular benchmark called the Yahoo Cloud Serving Benchmark. The characteristic of this benchmark is that it consists of a large number of independent objects between 8 and 100 bytes, and you're performing a mix of reads and writes. In this example, we are running the workload with a 50% mix of reads and writes, and this is being run on a 36-core server machine, and here we are storing the performance of the system. So for this 50% read-write mix, we see that we are able to achieve more than 150 million operations per second on a single machine. Now, here is the website of the GitHub of the Microsoft Faster, which you can go to at github.com/Microsoft/Faster, where you can see that it's very easy to use and also has versions in both C++ and C#. And to give you a flavor for how you embed it into your library, into your application as a library, I have an example here in Visual Studio of how you use Faster. The key idea is that you simply use it just like any other data structure that you may have in your high-level programming language. In this case, you simply create a new instance of the key value store, and then you can basically create what is called as a session with the system. So by calling start session, you can then perform a sequence of operations. These include operations such as upserts, in order to do an update of a data item with a new value, a read, which is basically to look up a particular key, and the read modify write operation, which is the atomic read modify write of taking an object and updating its counter, for example, incrementing it by 1. And you can do this at high efficiency, and you can also periodically call checkpoint on the system to be able to create a persistent snapshot of the data that is in memory as well. And finally, you end the session. Hopefully, this gives you a feel for how easy it is to use Faster. And we would love for you to kind of download the system, check it out, and use it in your applications as well. And if you're interested in this line of work, we have also done other projects which we would welcome you to check out. This includes Trill, which is a streaming analytics engine, which is also in C#, and FishStore, which is a really new system that is optimized for querying and processing JSON and flexible schema data in particular. Both of these are available through GitHub, or you can visit my website at badrish.net. Thank you very much.